This was my latest build here on the channel, a shop-made brushless milling spindle. You might ask, why am I showing you this? First, to make you click on the video about it, and second, well, there's no second. But joke aside, when building this spindle, I had to make quite a few small threads in the steel housing to hold everything together. On the front side, there are 6 M3 threads which hold the front cap in place. On the back side, there are 4 M2.5 threads for mounting the end cap. And inside the spindle, I had to tap 6 M2 threads for a ring which presses the bearings in place. So these threads are pretty tiny, at least compared to the size of a human hair. Anyway, if you ever worked with such small taps, you might know how nerve-wracking it can be when you have to machine these small threads in a steel part which you don't want to scrap. So I decided while building the milling spindle to make a tap stand for small taps next, which will minimize the risk of breaking taps and make tapping small holes a bit less stressful. The inspiration for this came from a Swiss-made device called the Gewinde Boy, which is a simple stand with a hand-driven spindle for easily tapping straight and square to the world's threads. And this is what I try to replicate now in a smaller version. I happen to have this small measuring stand flying around, which will make for a perfect base to start with. As said, I want to build a smaller version of the Gewinde Boy, perhaps up to the size of about M5 threads, I guess. For this thing looks fine. Only the measuring table seems to be a little too small for my taste. I will replace it with a little larger one. The original Gewinde Boy has a quick change mechanism with special holders for every tap size. As my version is only for small taps, I thought a small drill chuck might be fine, and bought this small Proxen 6mm chuck. I start the build with a massive 30 by 70mm steel bar, from which I plan to make the arm, which holds the thread cutting spindle. I mark the rough length and cut the raw part on the bandsaw. But oh man, that thing took ages to cut. And my machine can't cut alone. You have to stay there the whole time holding the power button and pressing the saw blade down. I really wish this thing cut automatically. I cleaned the top part on the milling machine and brought the part to the correct height before marking the positions for the 2 holes, one for the tapping spindle and the other one for mounting the arm to the stand. I roughly pre-drilled both holes on my drill press. It got a little violent with the larger drills, and the small drill press quite didn't like that. For finishing the holes and bringing them to their precise diameter, I had to get creative. As the part is too big to clamp in a lathe chuck, the only way of machining the bores is my self-made boring head. But I can't use it on my milling machine as it has a 20mm shank diameter, which is way too large for my mill. I can only clamp it in my mini lathe. So I removed the compound slide and mounted a small angle plate to the cross slide. After carefully aligning it, I can clamp the arm against it and finish machine the bores. As it isn't really critical here, I just align the part with a drill in the existing bore. Now I can mount the boring head in the collet chuck of my lathe and finish machine the 2 bores. And if you are interested, there is a 2-part build video about this boring head on my channel. I haven't used it very often yet, but when, it did a great job. Flipping the part over to machine the other bore. And that's the arm with the 2 finished holes. The fit on the stand is pretty good. And now let's add a few details to make the arm look a little bit more pleasant and more like a cast iron part. As I was too lazy to remove the milling vise, I just clamped the part on top of the vise jaws, which at the same time gave me the advantage of machining the whole height of the part, as there is a small gap between the underside of the part and the vise body. I first removed material on the top and the bottom of the arm to thin down the middle section. Luckily, I had an old high-speed steel end mill, which was long enough to clean the whole height of the part at once and made a really fine finish on it. And same thing on the other side. I wanted to mill a pocket on each side of the part to make the whole thing look a little bit cooler. For this, I roughly marked the contour for the first milling step with a normal end mill. In the second step, I will round the corners with a big 10mm radius end mill. Before milling the pockets, I first spared the small side of the part, which had still the rough surface from sawing. Then I pre-milled the pockets using a 5mm end mill. For finishing, I bought a 10mm carbide ball nose end mill to machine 5mm radii on all sides of the pockets. And redoing the same thing on the other side. And this is the arm with the finished pockets. On the first side, there is a little oopsie. There seems to be something wrong with my milling machine, especially regarding the Z-axis. When I clamp the Z-axis, the milling head jumps down about 0.5 mm, which caused these beautiful marks in the part. It seems that I have to put some work into my milling machine in the future. Next, I marked the hole position for the clamping lever. With a hole for clamping, the final length of the part was determined, and I could remove a few millimeters from the backside, where the part was a little bit too long. Again, I cleaned the rough cut on the milling machine using the extra long end mill and slotted the part so it can be clamped onto the stand for height adjustment. To tap the M5 thread for clamping, you see how I normally did tapping on my drill press. I remove the belt so that the drill chuck can spin freely and start the thread by hand cranking the chuck. This is to guarantee the straightness of the thread. I then finish the thread by hand on the bench. But all in all, it is a very annoying procedure, which I hope I can avoid in the future using my new tapping stand. The front side of the arm gets a hole for a small spring-pressured steel ball. This should keep the tapping spindle in the upper position for changing taps, for example. As a last step, I wanted to machine some nice big chamfers on the front edges of the arm. For this, I had to tilt the milling head of my machine at 45 degrees. I never did this before, so I accidentally loosened the screw for the Z-axis nut at first, before figuring out the right bolts to loose. But even with the right bolts loosened, the head was not able to swivel in the desired position until I found out that there is an indexing pin on the left side of the milling head, which of course has to be pulled out to make the milling head swivel freely. You can see the massive hollowness here in the aluminium casting of the milling head, so it's really not the best design in terms of rigidity. And finally, some fine chamfers with a hand file finished the arm part. Now only the bushings for the tapping spindle are missing. I plan to use 10mm bronze bushings, which get pressed in. To make this easier, I heated the part up on a small hot plate and pressed the bushings in with the help of a machine vise, as I still have no arbor press in my shop. After inserting, the bushings were a little bit too tight for the tapping spindle rod, so I reamed the bore back to 10mm. But obviously something went wrong here, as I just found out after everything was finally assembled in the end. Next part is the new table. I made it from a scrap piece of precision ground flat steel, which I had flying around in the right dimensions. I just had to clean all the 4 sides on the milling machine and machine small V-grooves on the top side to make the table look cooler, and they also help small chips to escape from under the workpiece. Unfortunately, my normal milling vise was too small to clamp the table, so I had to look for an alternative. Luckily, in my new room next door, there is another little gem sleeping, from which I just stole the Georgia's Röhm vise, which is capable of clamping the table part. For milling the grooves, I tilted the milling head again at 45 degrees. The backside of the table needs an M8 thread for mounting. Unfortunately, with my M8 tab, it was not possible to reach deep enough into the part due to the long tip of the tab. As I didn't have a broken one, I just bought a totally new M8 tab, just for cutting away the tip to make a bottoming tab out of it. Again, some nice chamfers finished the table part. And that's the finished table. Last but not least, I made the tapping spindle. It's cut from a piece of precision ground 10mm round steel bar. The Proxen drill chuck I'm going to use has a B10 taper, which in turn is needed on the spindle too. To set the compound slide of my lathe to the correct angle, I clamped the chuck in the collet chuck, adjusted it for perfect runout, and copied the angle to the compound slide using a dial test indicator. With the correct angle set, I now can cut the B10 taper on my tapping spindle. A short test fit with the chuck confirmed that we are not that far off. With blue marking fluid, I checked how good the chuck bears on the spindle and fine polished the taper afterwards with a small bench stone. For the spring-loaded steel ball mentioned earlier, the spindle needed a matching groove, which I machined with a 6mm button insert. And that's the finished tapping spindle. For the tapping handle, I bought a 50mm diameter plastic grip, which only needs 2 holes for 2 set screws to mount it onto the spindle. To have more leverage when tapping, I drilled 2 holes for 2 additional extension grips, which just get screwed into the handle. This is pretty similar to the original Gewinde Boy, but just everything a little smaller. Now, before painting and assembling everything, I wanted to address the little oopsies from before. I used some metal putty to fill the holes and sanded it flush afterwards, so that the happy little accidents completely disappear. The stand as well needed some work before being ready for painting. With a little bit of WD-40 and some steel wool and Scotch-Brite, I polished the steel column, and with some grinding pads I went over the painted surfaces. Out of laziness, I just painted over the old paint, which will make you scream on your screens, I know. I personally don't like that too, but on this small thing I just thought take it easy and just paint over it. But of course, you can definitely do that better. I decided to use bright gray as a color and used the same sponge painting technique which I already used on my slow-speed carbide grinder build. This gives pretty nice looking structured surfaces with very little effort. I'm not really sure if the bright color choice was the best one, but time will tell. Perhaps someday I will do a proper paint job in good old Reseda Grün, as we call it here. After drying, I had to remove some of the paint from the 3 points of contact for the table. On the arm, I decided to drill a seat for a special self-made washer to protect the paint against the clamping grip. I made this little steel washer off camera and cold blued it for better optical appearance. And these are finally all the parts ready for final assembly. I started with mounting the small drill chuck. Then I installed the bearing ball and spring. They were held in place by an M8 set screw, which I drilled out on the backside. Next, I assembled the handle and mounted it onto the tapping spindle. Now, just the table has to be screwed in place and the whole thing is finished. And that's the finished tapping stand, or my humble version of the famous Gewinde Boy. And here you can already see the problem. There is massive play in the tapping spindle bushing. I have no idea why, but while reaming the bore out, it got way too large towards the end. However, I did a short test cut with an M3 tap, but you see how the part is wobbling around on the table. I couldn't accept that and decided to press the bushings out again and replace it with new ones. I only had a different size in stock, so I made 2 brass inserts so that the bushings fit into the existing bore on the tapping arm. With the new bushings pressed in, the tapping spindle now spins perfectly free of play. As an option for clamping the workpieces while tapping, I bought one of the small centering vices from China. It looks pretty neat, but the spindle is incredibly tight when turning. However, I think this might be a useful device for small parts in the shop. And final test cut with an M3 tap. It is really satisfying to use that little tap stand. No worries about crooked threads or accidentally breaking tabs because of too much side forces anymore. So all in all, a really useful addition to the shop, I guess, which you will see used a lot in the future. I hope you enjoyed this build, thanks again for watching and till next.